At this time I want to do a numeric example of finding the area between curves. And then after we've completed the computation, we will go into an applied example that I'll explain to you in some detail. But for right now, this is just going to be fairly mechanical. So we're going to be looking for the area between this curve on the top, the blue curve, which is 5 minus x squared, and the black curve on the bottom, which is 2 minus 2x. Now, if I want to find the area between these two curves, it really is necessary that one be on top, the other be on the bottom, and then the area will be positive between them. Now, I'm going to look between this point right here, which is the point -1, 4. That's where the curves intersect on the left. And this point over here, which is +3, and I believe it's -3, but I'm not real sure what it is over there, but it's somewhere around -3. For what we're going to do, we don't really need to know that right now. And I want to find the area in between these curves. How would I do that? Well, I'm going to scroll down so that we can have some room to work here, and I'll set up the integrals and explain how we set those up and then evaluate them. And so I've left the functions here so we can see what the functions were. The curve on the top was a 5 minus x squared, and I'm going to find the area between them, so I'll take the difference, which is a 2 minus 2x, and let me, although I don't need them, let me put in parentheses right here to emphasize this is the top function, the f function. This is the function below, which is our g function, and I want the integral with respect to x, and so I have a dx there. And then we found that we really want the area between these curves from x is equal to -1 to x is equal to +3. And I would do the algebra before I did the calculus, and so I would integrate from -1 to 3. And what do I have here? I've got a 5 minus x squared minus 2 plus a 2x dx, and I would still not doing calculus but just rewriting the integral from -1 to 3. Now I've got a 5 minus 2, so that's going to be a 3. And then in the order here doesn't matter. Maybe I'll just keep them in the order that they are. Minus x squared, and then a plus 2x dx. All right, so we know that what we do is to find an antiderivative of the integrand, which is this much right here, between the 3 minus x squared plus 2x. That's my integrand. I want to find an antiderivative. That's a polynomial, and so I can do that by inspection. So by inspection, the antiderivative would be 3x minus x cubed over 3 plus 2x squared over 2. And there's an antiderivative, and it's a definite integral, so I'll have to evaluate that between -1 and 3. And evaluating means I'll plug in the value, x equal 3, write down the expression, then I will subtract what I get when I plug in the value x equal -1. So let me, even before I scroll, let me just start writing this down with 3 in place of x. And so it would be 3 times 3 minus 3 cubed over 3. I've never seen so many 3's. Plus, and here I think, recognize that as 2 over 2, so that's going to be 1. So I'm just going to simplify just a little bit right here and write this as a 3 squared. Now that's the first part, and then minus what I get when I put a negative 1 in. And so when I put in a negative 1, I would have a 3 times a negative 1 minus negative 1 cubed over 3 plus, and this is where we've got the 2 over 2, we'll just recognize that that's going to be 1, and this will be a negative 1 squared. And let's scroll. I'd like to have lots of room to work. Now doing the evaluations here. This part's arithmetic. Interesting problem. We've used algebra and then calculus, and now we're using arithmetic. So this is going to be 9 minus, this would be 3 cubed over 3 would be 3 squared, so that's a 9, plus 3 squared is a 9, minus, I think I'll keep the parentheses here so I don't have to worry about changing signs as I go through. 3 times negative 1 would be a negative 3. Negative 1 cubed would be a negative 1, and I've got a negative out here, so this looks like this would be a plus 1/3. And then negative 1 squared would be 1, and so this would be a plus 1 equals, now we'll further simplify, here's a 9 and a negative 9, and so all that's left out of those first 3 terms is a 9. Let's just keep the negative in front of the parentheses for right now. So here's a negative 3, and a 1 would be a negative 2. So I've got a negative 2 and a positive 1/3 would be a negative 1 2/3. And maybe I should write that, well, I'll write it as negative 1 2/3. I was going to say an improper fraction, but we'll get to that as an improper fraction in the next line. I think when we tend to do too much at once is when we start making mistakes. So now I've got a 9 plus negative and a negative, and 1 2/3 would be 5/3, would be 5/3, and I can write that as 9 5/3, or that's really is an improper fraction, isn't it? 9 3s are 27, and 5 would be 32 thirds. Okay, and if that's not the correct answer, I'll apologize and correct it in a bit. But that was how we found the area between two curves. So 32 thirds is what we think the area, we can double check our arithmetic, but that's what we think the area between these two curves would be, 32 thirds. And remember, we're looking for the area between the curves from this point, all this area, over to this point. There's not really an area between the blue and the black after this point or before this point because they're flippy-floppy. All right, so for right now, that will do. Thank you.